Before I move on, I need to show you exactly what I did to cobble this meter into the charger unit. I need to do this because I really didn't get the best angles when I shot this, and I apologize for that. But even if I did get good angles and good close-ups, you really can't tell what I'm doing. You can just see that I'm cutting a wire here and drilling a hole there and splicing in the meter, but you can't tell electronically what I'm doing. So essentially there are just two wires coming out of the charger unit that I need to tap into to get the meter in there. So I simply cut the wire that was going to the negative side of the battery and spliced the meter in there for measuring current, and then took the red wire from the meter and had to attach it somewhere that the wire that comes from the positive side of the battery connects to. So I just had to look on the circuit board. It's pretty easy to see where those wires came from and which one to cut and which one to tap into. So you can use what I'm going to tell you now to either repeat what I did to the same charging unit, or do this to some other charging unit or some other circuit. So I'm going to tell you exactly what I did electronically so you can understand this project. So remember from your reading material and previous videos that voltage is always a difference. When you measure voltage, you're always comparing one voltage to another. So I need to have two leads of a meter to touch to one part of the circuit and to another part of the circuit, and the meter tells me the difference between the two voltages at those parts of the circuit. And that's pretty simple when just measuring the voltage of a battery. I just need to touch the black lead to the negative side of the battery and the red lead to the positive side of the battery. That powers the meter and tells me what the voltage is. Easy peasy. But measuring current's a little different, because remember, to measure current, unless you have a clamp type meter, which we are not using here, you have to break the circuit, and the meter has to become part of the circuit and has to be put in series with the load that the current is flowing through, so that the current goes through the meter and through the load in a series circuit. So remember, in a series circuit, what goes through one part has to go through the other part, so whatever goes through the battery has to also go through the meter. So we just need to find a place to cut the wires and splice the meter in. Now the first place you might think of is to put it on the positive side of the circuit, because the conventional current comes out of the charger and then goes into the positive side of the battery, exits the negative side of the battery, and goes back into the charging unit. So all we need to do is intercept it before it gets to the battery, send it through our meter, and we have them reading. So if we cut the positive side, intercept the current with the yellow wire coming from the charging unit, and then take it back to the battery with the black wire, we could measure the current. However, with this particular meter, we have to use the black wire as a common connection between both the current and the voltage measurement. So that won't work, because to measure the voltage, we have to have the black wire to the negative side of the battery. So how are we going to do it? What we need to do is measure on the negative side. It doesn't matter whether we put the meter on the positive side or the negative side, as long as it is in series with the battery. As long as the current goes through the battery and then goes through the meter in series, we will get the current going through both, and we can make the measurement. So let's cut this on the negative side. And so now we have the conventional current exiting the negative side of the battery, and we intercept that with the yellow wire from the meter. Then we take the black wire from the meter and go back to the charging unit, and that will intercept the current, and we get a valid current reading. So now we see the current goes into the battery, out of the battery, into the meter, out of the meter, and into the charging unit. All we have to do now is connect the red wire to somewhere in the unit that connects to the positive side of the battery. So we're going to look inside there, and we're going to find the wire that goes to the negative side of the battery, cut it, put the yellow wire on the side that goes to the battery, the black wire that goes back to the meter, and then we just have to find some place to connect the red wire to the wire that goes to the positive side of the battery. In this case, we're going to drill a hole in the circuit board, feed it through, and just solder it to a little piece of copper that happens to be conveniently placed so that we can do that. There is a slight problem. If you look carefully, you'll see that we are not only measuring the voltage across the battery, but are also measuring the voltage across the current meter. Is this a problem? Well, remember that a current meter should have a very low impedance. In fact, a perfect current meter would have zero impedance. It would actually be a short circuit. And therefore, it would just be acting like a piece of wire going between the battery and the charger and wouldn't affect the circuit. But this is not a perfect world, and our meter does have some impedance. So is it enough to skew the voltage reading enough to make a difference? Well, this particular meter develops about 10 millivolts for every amp that's going through it. So at the maximum current of this charger of 8 amps, we're only going to get about 80 millivolts across the meter, or 8/100ths of a volt. So our maximum error is 8/100ths of a volt, and that's not enough to really matter. So even though this is not a perfect way to hook it up, it's the only practical way, and it is close enough. We are not getting enough of a voltage across the meter to skew its reading. Now you might have a different meter than the one I have here. So this meter is the YB27VA, and it's a 10 amp version, so we don't have to have any external circuitry to measure up to 10 amps. And it only has 3 wires, and we're going to hook it up as I'm going to show you. But if you buy a meter like this, you'll find that most of them actually have 5 wires. An example is the DSN VC288, and it has 2 heavy wires for measuring current, and then 3 lighter gauge wires for delivering power to the meter and for measuring voltage. So to hook it up, it's very similar. We have the same problem in that the black wire has to be a common connection to both the voltage and the current, and instead of a yellow wire to intercept the current, it's a heavy red wire. So as you can see here, the heavy red wire goes to the negative side of the battery, the heavy black wire goes back to the charging unit, and that intercepts the current. And to power the meter, we have to send the light red wire to the positive side of the battery. But with this meter, we're measuring the voltage with the light gauge yellow wire, which has to be connected to the positive side of the battery. And since the red wire is already going there, we just have to connect the red wire and the yellow wire together and connect them to the positive side of the battery. And that's how you would wire this particular one in. We don't need to connect the small black wire to anything in this case. That's only needed if we need to measure higher voltages, up around 100 volts or so, and we're not going to be measuring such high voltages, so we leave that disconnected. Now the ZC15400 is very similar to the DSN VC288, except we do need to connect the small black wire to the negative side, so that goes to the same place as the heavy black wire. And we don't have a yellow wire, we just have a heavy red wire for measuring the current and a light gauge red wire for powering the unit, and so those just simply go together. And notice that instead of a red or yellow wire to intercept the current, we have a blue wire. So the blue wire goes to the negative side of the battery, the heavy black wire goes to the charging unit, the heavy red wire and the light red wire go together and go to the positive side of the battery, and the light black wire goes to the same place as the heavy black wire. So I have not used these particular units, so I don't guarantee that they'll work because I haven't actually tried them, but I got these schematics off the internet and they should work this way. But your mileage may vary. But anyway, we're going to use the YB27VA 10 amp version with only 3 wires, a little easier to hook up, and if you can find it, it's easier to do, but there's how you do it with any of the 3 units. So let's go on and cobble this in. Let's get this fan out of the way here. Yeah, make sure I'm cutting the right thing here. Let's tin these. And have some nice white heat shrink here, which will shrink enough to do the job. There we go. Now, okay, move our heat shrink into place, and notice I get the heat shrink well into the blue part of the flame. Just going to drill a little hole that comes through these right there, those little pieces of solder. I'm not quite sure what the point of that is, but I'm going to use that as a place to hook up my positive. Okay, we're through. So we can get something that resembles a decent connection here. Okay, now let's go see if this thing blows up if we plug it in. Okay, here comes the moment of truth. I'm going to try this out before I button it up. See if it blows up or anything. So there's my battery. Let's flip this around so we can see the display. Let's just plug it in and see if it blows up. Heard a little click, but nothing I don't expect. What happens if I push the start button? It tries to charge. Look at that. Let's put it on the battery and see if it actually works. Oh, look at that. It's powered up. It says we have 12.7 volts. Can you see that through the thing there? Well, that's a good sign. It's reading the battery voltage, 12.6 volts. So, let's see what happens when I power it on. Okay, it takes a few seconds to fire up. There it goes. And went with 13.2 volts. Now this doesn't start firing the current in the right away. It ramps up slowly. As you can see, it's going up to 2 amps, getting close to 3. Let's see if they agree on voltage here. Might help if I put these the right way. And we're up to, it says we're up to 15.2 and 14.6 volts. They're disagreeing on the voltage. There we go, 14.8, 14. So they're off by several tenths of a volt, but it appears to be working. So now the next thing I need to do is just let's unplug this guy. Disconnect him from the battery so he's not powered. And now I have to cut a hole so that we can put our display right there.